in chemical bonding, we have to study the formal charge also. Formal charge is the charge present on individual atom in neutral molecule or ion. How we can calculate it? Formal charge is equal to total valence shell electron minus half of shared pair of electron and minus total lone pair electron. In short, VSL. V minus half of S. S stands for shared pair and L is lone pair. For example, O3. First of all, we will make the Lewis dot structure of ozone. Every oxygen is having 6 valence shell electrons. So you can see by the help of dots I have made the 6 electrons on the center oxygen also and on this oxygen also, third one. Here the formation of double bond will take place between two oxygen atoms. As we know, oxygen always form double bond. When the third oxygen will join with the ozone with the oxygen, by the donation of this lone pair of electron, the coordinate bond is formed. Because this oxygen is having complete octet, now it cannot combine by the help of covalent bond with the third oxygen. That's why the coordinate bond is formed. For example, I have just marked them number 1, 2 and 3 to find out the formal charge. On the first oxygen, how many valence electrons are present? They are 6. Minus half of shared pair of electron, you can see there are 4 shared pair, minus how many lone pairs it have? It have 2 lone pair and the 4 electrons. So when you will calculate, it will come 0. That means the first oxygen have 0 formal charge. Now we will calculate it on the second oxygen. Valence electron are 6 minus half of how many shared pair of electron it have. So 4 are here and 2 is this one, which those are forming the coordinate bond. So 6 electron are the shared pair, minus lone pair are left only 1, so 2 electron we will write, and as a result the second oxygen will have plus 1 charge. On the third one, if you will see, valence shell electron are 6 minus half into shared pair of electron are 2. Mind it, these 2 electrons of dative bond will calculate in second and third oxygen both. So minus half into 2, minus 6 are the lone pair. There are 3 lone pair, that means 6 electrons it have. So the formal charge will come minus 1. Now we want to calculate the formal charge in perchlorate ion. Perchlorate ion. ClO4 minus is perchlorate ion, which is formed when the HClO4 perchloric acid donates H plus ion. We will calculate the formal charge on chlorine after writing the Lewis dot structure of perchlorate ion. Here this dot electron is donated by hydrogen. H plus is removed and hydrogen given the electron to this oxygen. Now on chlorine there are 7 valence shell electrons, 3s2 3 pi is the configuration valence shell, minus half into total bonding electron you can calculate 4. These are 4, 8, 12 and these 2 are 14, and you will have, there is no lone pair now on chlorine, so the formal charge will come 0. On first oxygen, for example, if we will calculate the formal charge, valence shell electron are 6 minus half of shared pair of electron are 2, you can see 2, minus how many lone pair electrons are present? So there is 2, 2, 4 and 2, 6. So it will come minus 1. On second oxygen, second, third and fourth oxygen number oxygen will behave as the same way, as all 3 are double bonded with each other. Valence shell electron are 6 minus half of shared pair of electron are 4 and there is a 2 lone pair, that means these 2 lone pair as 4. So the formal charge of second, third and fourth oxygen will be 0. Here today we will see the overlapping between the orbitals. Mind it, in covalent bonds we see that there is a equal sharing of electron. Electrons are living in orbitals. When the electron will share, naturally the orbital will also share. So how they share? This sharing of orbital is known as overlapping. There may be 4 kinds of overlapping normally: SS overlapping, PZ overlapping, SPZ overlapping, PX or PY overlapping. First of all, we will do SS overlapping. We can take the example of hydrogen. When the 2 hydrogens combine together, they form single covalent bond. There is a configuration of hydrogen is 1s1. S is having a spherical shape, so both the hydrogen will have the spherical shape. Here, when they will come closer, overlapping will take place. This is overlapping region. As a result, when SS orbital combines, there is a formation of sigma bond. This is the combination of 2 spheres which we have shown like this. PZ overlapping can be seen in fluorine, chlorine, as unpaired electron is present in PZ orbital. Cl when combined together, the single covalent bond is formed between the 2 Cl atoms. PZ is having the double shape, so when the 2 doubles will come closer, so when they will closer, they will do the overlapping, and as a result, once again the sigma bond is formed. SPZ overlapping, and what happens in SPZ? We can take the example of HCl. H is having unpaired electron in S orbital, Cl is having in PZ. So sphere and double when share with each other, they will share like this, and as a result this kind of sigma bond is formed. How the PX or PY overlapping takes place? These three sigma bonds are formed by coaxial overlapping. While the PX or PY overlap with each other in a collateral way or side way overlapping. It is like this, side way. It always takes place after the formation of sigma bond. Pi bond will form after the formation of sigma bond. I have taken 2 PX. Here we can take PY also. So when they will overlap with each other, as a result the pi bond is formed like this. In double bond and triple bond, pi bonds are always present. In double bond, 1 sigma and 1 pi. In triple bond, 2 pi and 1 sigma is always present. Sigma bond is always stronger than pi bond because overlapping region is more in sigma bonds in comparison to pi bonds. So this was all about overlapping.